In this video, I'm going to introduce the idea of analysis of algorithms, which is something you may have heard of before. The goal for this video is you have some idea of why it's interesting or important for us to have the ability to analyze programs. So let's consider the following. Let's say, it's maybe your senior year of your program, right? You're set to go out in the industry and hey, you managed to get an internship, for your last semester, to prepare you to go outside. Maybe, you get lucky and they hire you afterwards. So you have a great internship, but then also, right, there's a few other people that have been hired at the same time as you. That's great, except that at the end of the semester, there's only going to be one position. So you're there with several other interns, right? And you have to ask yourself, how do you make sure that your work maybe is, shines above the rest, right? How do you make it clear that you're better, right? How can you demonstrate, right, that you're the person that they want for their position at the end of the day? That's something analysis of algorithms actually do, right? So think about, right, you have this potential internship, right, and you're maybe given, everybody gets the same problem maybe to work on, and then after, the 4 months are up, everybody kind of has to give a demonstration of what they've done, say, this is how I solved the problem, and, whoever has the best solution, that's going to be the person that's hired. So just imagine that for a second. Well, if you're there at the end of the semester, standing next to 3 other people and you've all solved the same problem, how are you going to be able to justify that, your solution is the best one, that it is maybe the fastest, that it maybe takes less space or whatever? Right now, you don't really have any tools to do that. So we're kind of used to maybe from introductory courses, just the idea of, oh, I'm given a problem and I solve it, and that's great, right? I can press F5, I can run it, I can get back the answer to whatever is the input that I put in. But well, there's tons of different ways to solve a problem, right? You have a solution, all the other interns at your company maybe have a solution. How do we judge those? What we need is some way to look at programs and say, okay, this is how they act, right? Maybe this is how fast it is, right? This is how much space it uses. We want a precise way to state those things. And ultimately, that's what analysis of algorithms will do. It'll give us a way to characterize programs and figure out how exactly they act when they run. So a very simple way to characterize programs, perhaps, is to say, okay, in terms of something like performance, maybe 2 programs, A and B, run approximately in the same amount of time, right? Versus maybe program C runs in a completely different amount of time. This is kind of the simplest way we can organize things, right? So you can imagine we can make piles of programs, and each pile or each bucket, those programs are roughly equivalent. Okay, so it's kind of the bird's eye view here. And so what we want to look at, right, is basically saying, okay, we need to have a way to categorize or characterize, right, our programs, right, our solutions into those different buckets, right? And those buckets hopefully have some sort of ordering on them, right? So the programs in the first bucket maybe are faster than programs in the second bucket. So that we know that A and B in that first bucket, just by the nature of what bucket they're in, they're going to be faster than that program C that's in bucket 2. So we have a couple things happening there, right? We want to take our programs and categorize them, and then once we have them into categories, hopefully those categories have enough meaning behind the scenes that there is some sort of ordering or rank that is implied about the programs that are in those buckets. So that's what we're going to look at. We're going to look at a few different ways to characterize programs. The main one that you guys have probably heard of before is something called Big O. Big O basically is going to characterize the long time performance or character or behavior of a program, right, when you have very, very large inputs. As a final note there, one real goal here is we want a generic way to measure things. So there are maybe tons of different ways you could characterize programs. Maybe you would think, oh, I can maybe look for I can say that a program is maybe better than another program because it has fewer lines of code. There are tons of different things we could think about doing. But one thing that we're going to kind of keep in the back of our head this whole time is that we want a generic way. So even though we're kind of constrained to Java in this course, what we want to do is we want to talk about techniques that can be used in basically any programming language, right? Because we're going to have all sorts of implementations. You have all sorts of different programming languages. Maybe, right, if you're at a company and you're trying to choose, what third-party library you want to use to solve a problem, while they're going to be implemented maybe in different programming languages. In which case, however you analyze and compare those, there needs to be something that's very generic, right, or something that can kind of capture all those different languages. So we want to keep things as generic as possible. What that'll mean for us at the end of the day is that we will have to spend some time talking about mathematics rather than just Java itself. So in the next videos, we're going to start to introduce the overall idea, right, of analyzing a program.